I'm sure you've heard the news. The future is here, and it's electrifying. On this channel we dive deep into the world of electronics repair and reviews, making tech accessible and exciting for everyone. Whether you're a seasoned pro or just starting out, we've got something for you. From fixing your broken gadgets to reviewing the latest tech, we cover it all with a beginner-friendly approach. Imagine fixing that old smartphone yourself, or knowing which gadget is worth your hard-earned money. Join our growing community of tech lovers where learning and fun go hand in hand. With easy-to-follow tutorials, in-depth reviews, and a splash of humor, you'll be empowered to tackle electronics like a pro. So, hit that subscribe button and turn on notifications, because you won't want to miss our upcoming videos. Let's explore, repair, and reimagine the world of electronics together. Welcome to Electrotechnics, your go-to for electronics. Join our growing community of tech lovers where learning and fun go hand in hand. To the electrifying world of electronics. Today let's talk about a tiny but crucial part of electronics, a component so small yet so mighty that it's found in almost every electronic device you can imagine. I'm talking about the resistor. Imagine electricity as a crowd of electrons, a bustling group all trying to move at once. Imagine them rushing down a highway, all heading to their destination. A resistor is like a traffic cop, standing there slowing them down, managing the flow. It doesn't stop the flow completely. The electrons still get where they need to go, just makes it harder for electricity to pass, creating a bit of a bottleneck. It's all about controlling how much gets through, regulating the current. Think of a wide freeway, lots of lanes, smooth sailing for all the cars. Now imagine that freeway suddenly narrowing, maybe due to construction. All those cars, electrons, have to slow and squeeze through, creating a controlled congestion. That's resistance in a nutshell. Resistors are made of materials that aren't great at conducting electricity. They offer some opposition to the flow, but they're not terrible either. They allow some current to pass, just not as freely. It's just enough to slow things down, providing that crucial control. This slowing effect is measured in ohms, the unit of resistance. It's named after Georg Ohm, a brilliant scientist who studied electrical resistance. High ohms mean more resistance, a greater slowdown of the electrical current, and low ohms mean less resistance, allowing the current to flow more easily. Each resistor has a specific value, indicating how much it will resist the flow of electricity. This value is often shown by colorful stripes painted directly on the resistor. These stripes are a code for engineers to read, allowing them to quickly identify the resistor's value. By carefully choosing the right resistor for the job, we can precisely control the flow of electricity in every part of a circuit, ensuring everything works as intended. It's a simple idea, this concept of resistance, but it's the fundamental building block, the very foundation of all modern electronics. So, next time you use a gadget, whether it's a phone, a computer, or anything else, remember that resistors are quietly making it all work, regulating the flow of electricity behind the scenes. That's science in action, folks. Keep exploring. To understand resistors, picture a crowded hallway, a place where many people are trying to move from one point to another. When the hallway narrows, you have to slow down and move single file. This creates a bottleneck, controlling the flow of people. That's fundamentally what a resistor does to electrons in an electrical circuit. It restricts their flow. Or think of water in a pipe. Imagine a steady stream flowing smoothly. If there's a narrow section, it slows the flow, creating resistance to the water's movement, just like a resistor controls electric current. As electrons push through this resistance, they lose some of their energy in the process, which turns into heat, like rubbing your hands together to generate warmth through friction. In devices like toasters and electric heaters, resistors are specifically designed to get hot on purpose, converting electrical energy into heat. Whether it's a hallway, representing a restriction of movement, a pipe, constricting the flow of water, or friction, generating heat from movement, the underlying idea is the same. Resistors create a controlled bottleneck for the flow of electricity. They're not a flaw or an imperfection in the circuit. They're absolutely essential for managing and controlling the flow of energy within circuits. Without resistors to regulate the current, electricity would flow unchecked and unregulated, potentially damaging sensitive components due to excessive current. Resistors give engineers the power to precisely direct and manage electrical energy, ensuring circuits operate as intended. They're a fundamental reason why our electronic devices work safely, reliably, and predictably. Simple in design but incredibly powerful in function. That's the magic and the importance of electrical resistance. let's delve deeper and see why circuits absolutely need them to function correctly. Why control the flow of electricity within a circuit? It might seem counterintuitive at first. Because different parts of a circuit, from microchips to sensors, need different amounts of electricity to function correctly. Each component has its own specific power requirements. Take an LED, too much current surging through it, and it burns out almost instantly, rendering it useless. A resistor protects it by limiting the current, acting as a gatekeeper to ensure the LED receives only the electricity it can handle. Resistors also help divide voltage, creating specific voltage levels needed for different parts of the circuit. This is especially useful, letting us power different components, each with its own voltage requirement, from a single battery source. With two resistors configured as a voltage divider, we can tap off just the right voltage for each part, ensuring optimal performance. Pair a resistor with a capacitor in what's known as an RC circuit, and you get a timer, a fundamental building block in many electronic systems. This timing mechanism is what controls things like the blinking light on your computer, indicating activity or status. By carefully choosing resistor values, selecting the right resistance for the job, we control how fast things happen in a circuit, dictating the speed and responsiveness of electronic functions. Without resistors to guide it, current would take the easiest, most direct path, often overloading components. This can lead to short circuits, component failure, and irreversible damage to the entire circuit. Resistors direct the flow, ensuring that each component receives the correct amount of power, keeping everything safe and stable. They're the unsung heroes of electronics, quietly working behind the scenes to ensure everything functions as intended. Every reliable gadget, from your smartphone to your refrigerator, owes them thanks for their consistent and dependable operation. Let's take a closer look at where you use them every day, often without even realizing they're there. Resistors are hidden inside almost every device you own. Your smartphone, packed with thousands of tiny resistors, making sure every part gets the right signal. Adjusting your screen brightness? That's a resistor at work. TVs and monitors use resistors to control colors and power to each pixel. The volume knob on your speakers? It's a special resistor called a potentiometer. In your kitchen, the glowing wires in your toaster are powerful resistors, heating up to toast your bread. The same goes for electric stoves and hair dryers. Resistors turn electricity into heat. Even your car uses resistors for dashboard gauges, wipers, and indicator lights. From computers to simple blinking lights, resistors keep everything running smoothly. They're everywhere, working behind the scenes. Without them, electronics wouldn't work at all. Now let's see why they're true superstars. Let's wrap up. Resistors may look simple, but their job is huge. By slowing down electricity, they protect delicate parts, divide voltages, and create timers. They even turn electricity into heat for toasters and heaters. Every device you use relies on resistors to keep things under control. They're the traffic cops and guardians of the electronic world. Without them, our gadgets would be chaos. The humble resistor is a true superstar of science. It's a small part with a massive impact. Understanding resistors is the first step to understanding electronics. Pretty cool, huh?